Alright, welcome back to the second lesson here in Unit 5. It's Mr. O again. I hope you're having a good day. We are going to learn today the first algebraic method for solving systems of equations, and we call that one, of course, the substitution method. Our job will be to solve systems of equations algebraically by using this method called substitution method. You have seen it before in 8th grade, and you get to revisit it again now, and we might go into a few harder problems in 8th grade. But hang in there, it should come back to you. Alright, as we go into this here, before we actually get it, we're going to go back and revisit again, checking to make sure we already know that the solution here is 4 ones for the following system. Make sure it works. So we plug stuff in again, once again. So we have 2 times, we're going to plug a 4 in here. Plus y is 1, has to equal 9. So you get 8 plus 1 has to equal 9. 9 equals 9. It works in the one equation. But if you remember correctly, you got to always make sure it works in both. So in the other one here, we're going to plug 1 in for y, and that has to equal, plug 4 in for x minus 3. Well, you know that 4 minus 3 is 1. So it sure indeed works for both. No problem. Well, part B, if you want to plug that in and substitute x minus 3 into the first equation and show that it still works, I'm going to let you do that. It will work. If you have any questions, please ask for that in class. I'm going to go right to the heart and the meat of this, which is part C, solving the system's equations. And this is where we're going to go. Whenever we're doing substitution here, you're looking for like x equals or y equals. And if you look right here, we got a y equals. So we take the part that y equals, which is called x minus 3 here, and we actually replace y in the other equation with that x minus 3. So what you get here is 2x, and instead of plus y, you're going to have now plus x minus 3. Okay, we're replacing that. I'm trying to fix my x here a little better. And that has to equal 9. Okay. Then what do? You just solve it like you normally do. What is 2x plus 1x? Well, that's 3x. And 3x minus 3 has to equal 9. And then you do your little math. You add your 3 from one side to the other because x's are already all on the left. And you'll get 3x then. These are gone. Equals 12. And divide by 3. And when I do that, I get x equals 4. Now, if you remember, we have to have 2 answers. And if you go all the way back up here to the top, the answer is 4 comma 1. Well, what did you figure out? Just the x part. So that is true, and you got part of the answer, but you need the other part. So 4 comma, we know the other part's going to be 1 because they already told us. But how do you do this? Well, take this x equals 4 part, and you can put it back into either equation. Now, obviously, I'm looking for the y since I now know what x is equal to. So if you look at it, isn't this y equals this? I like this equation better. So I'm going to plug it back in right here for that. So I'm going to rewrite this problem. And I'm going to write it over here. Y equals, and it's x minus 3. And now that we know y x is 4, we put it in 4 minus 3. And what's 4 minus 3? It's 1. So there's my y answer. Stick it in. And you've got your answer. There's your solution for this whole thing. So we're all good. We already know it was the answer because they told it to us. But if not, you would then take this answer right here and plug it back into the 2 equations and make sure it works in both. We did that in part A already. So it's kind of like redundant to do that again. All right, let's move on to example 2. Now we're going to get a little practice on these just to show you. So here's the deal with this one, though. If you notice, they're both in y equals form, aren't they? They're both set up perfectly to graph, which, by the way, you could go and graph on your calculator and find the answer and see where they cross from yesterday's lesson, okay? But we're going to solve it using substitution, and I would use the calculator as a good check unless they force you to do it by hand. So here we go. It doesn't matter which one you plug into which. I personally am just going to take this one and put it into y right here. So it means that on the left side, I get 2x plus 5 equals the right side, negative 3x minus 10. I didn't do anything to the right. I just replaced this whole y right here with what y was equal to in the other equation. Now you've got to solve. Well, what are you going to start moving? You can't reduce or combine anything on either side, so you got to move stuff around. I personally, there are more x's on the left because there's 2x, so I would do the opposite of a minus 3x, and I would add 3x to the left side, both sides. So now I get 5x here plus 5 equals, this is gone, negative 10. I got my x's all on the left now, so it's time to move that 5. You could have done that in the last step if you're getting really good at these and do it all at once. So 5x, these cancel, equal negative 15. And your last step, divide by 5. So x turns out to be a negative 3. Now the big error is, kids say, oh, I'm done, I found x. No, you're not done. You've got to remember, you're doing a system equation. You found the x part of the answer. I still have to figure out the y. What am I going to do? I'm going to take this answer and put it back into either one of these equations. It is up to you. I personally like that first one there, so I'm going to put it into this one here. I'm going to take that answer now and stick it in right there. So I'm going to get y equals 2 times a negative 3 plus 5. So I get negative 6 plus 5. And when I do that, I get a negative 1. That's the y part. So stick that answer in down here, and there's your solution. Once again, your best bet is to check it either by the graphing calculator or plug the answer back into both equations. I want you to pause the video right now, and I want you to try 2b. Okay, that's what I asked you to do. Pause and try 2b. Okay, hopefully you got an answer of 3, negative 2. But I want you to show your work. If you didn't get that, please ask questions right away in class tomorrow. And we will check to make sure you showed your work, okay? We don't want just an answer. I don't want you just cheating going on the calculator. It's not a multiple choice type question where you could do that. I want you to show your work. So make sure you've done it and you do it right, and we will give you credit for your homework that way, full credit. All right, we're going to move on to the last one. All right, now we have a few word problems. I'm not going to go over all of them, but we're going to go over parts here. We're going to start with exercise 3, and it basically says Max and his father Kirk, are comparing their ages. And it shows that the sum of their ages is 52, and that Kirk is 7 years older than 4 times Max's age. All right, write a system of algebraic equations, and they also want you to solve for their ages, okay? They tell you in part A to let Max's age be represented by M, and Kirk's age be represented by K. Well, we need to write a couple of things. Well, first of all, we know the sum of their ages. So remember, that's the sum of their ages here is 52. So when I'm doing this, well, Max's age is M. Kirk's age, try to fix that, is K. And you should remember the sum means to add. So the sum of their ages is equals 52. There's one equation. The other one we're talking about here is he says that Kirk's age up here, Kirk is 7 years older than 4 times Max's age. So Kirk age means equals 7 years older than, so that's 7 years more than. I like that more than to kick that 7 at the end. You can write it first though, because it's commutative there. But 4 times Max's age, so 4m. So Kirk is 7 years older than 4 times Max's age. And we got our two equations. So that's part A. Now we want to take those two and solve. Well, once again, we're trying to use this in this lesson here, the substitution method. So if you take a look here, I know what K is equal to. Here, M and K are together. You would have to move one to the other side or whatever if you want to get it in a nice, kind of like that old Y equals form. But here we got K by itself. So let's take that and take this 4m plus 7 and put it in for K right there, okay? So I'm going to rewrite this problem as m plus, instead of K, we now put in 4m plus 7. And then that equals 52. So it's the same first equation, except we replace the K with this 4m plus 7 part. All right, now we got to combine things. Well, you should know 4m plus 1m is 5m plus 7 equals 52. This turns out to be not a hard problem. It's a three-stepper. Move the 7 to the other side. You get 5m equals 45. And then divide by 5. So when you get there, you figure out that m is equal to 9. So we now know that Max here is 9 years old. Okay? But we don't know Kirk yet. Hence the substitution again. We substitute the one part in. Now we're going to take this m, put it in here. You got the other equation for K. So K equals 4 times 9, and then you got to add 7. So 36 plus 7, and that gives you Kirk is 43 years old. So there's your other answer. Kirk is 43, and there are your answers. Obviously, you should check the two equations in there. Go back and look at it. Do the sum of the two add up to 52? Sure. If you add 9 on to 43, you'll get 52. Is Kirk 7 years older than 4 times Max's age? Well, 4 times Max's age is 36, plus the 7 is the 43. So we know that already works on that part. All right, but definitely check it both either by graphing, using your graphing calculator, or by hand. Time to move on. One more we're going to do. All right, on to example 4. It says 2 cell phone plans offer different text packages. They are outlined as follows. Plan A is telling you you've got $5 a month plus 3 cents per text. And plan B is just 10 cents per text. Then there's no monthly charge. So they ask us basically, is there a certain number of texts when the two plans cost the same amount? Determine your answer by setting up a system of equations for the two plans. Well, let's deal with this. We got plan A here, okay? And I want to know its cost for a month or whatever. Well, the cost is going to be equal to what? Well, they got a flat fee of $5, and that's 3 cents per text. So 3 cents for every text means I'm going to take 0.03 times every text. I'll call that T. If you want to call it X, is fine. Plus a flat $5 per month. Since it comes out nice, I'm just going to call it 5. We'll go from there. Plan B, on the other hand, its cost would be equal to 10 cents for every text and plus no startup cost. So I can put a plus 0 in there if I want, or I just write it that way. Now that's setting up your equations. Now we got to solve them. Well, we want to know when the two costs are the same. So the bottom line here is you can set them, if you want, equal to each other, or you can use our method here, which is called substitution. And I'm going to take the cost of this one and put it in for that C right there. Because the same cost, they want to know when they're both C's, so two C's are the same. So I get 0.10 cents T equals 0.03 T plus $5. Well, when I go to solve that now, obviously there's more cents on the left with the 10 cents, so I'm going to move the 3 cents to the left. So I'll subtract that off. And I will get 0.07 T equals just 5, because these cancel. That's why we did it. And your last step is to divide by 0.07. Divide by 0.07. So T turns out to be 71, if you use your calculator, 0.42857, blah, 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 and it keeps going. Well, this is a trick question by Mr. Weiler here on with his question on that. And the bottom line is there is no perfect set amount like 72 texts. If I was rounding off when about they cross, yeah, they cross right around 71, 72 texts. But the bottom line is that there is no set nice number that works. So the bottom line is you cannot have a fractional text. So the answer is no, because you cannot have fractional tests. And that's what we're going to write down. Have fractional, texts. So it's a trick question. Yes, right around that mark, 71.4, but you can't have a half text. So bottom line is that was a little bit of a trick question here, but it's not hard, and we use substitution up here, and you are able to do that in these type of things. Give it a try in number 5 and see if you can do that, and we will check on that one as well in class tomorrow. Don't forget to write a nice WSQ. All right, have a good one.